On this 6.7 power stroke charging system, P0562 is a low system voltage code. In plain shop terms, the PCM is seeing system voltage fall below what the charging system is being commanded to deliver. The truck may show charging warnings, a weak or discharged battery, intermittent electrical complaints, or possible starting issues. Broadly, think possible battery condition, belt drive problems, high current connections, grounds, generator output, battery monitoring, or PCM power and ground feedback. For this code, the set condition is voltage dropping 1.5 volts or more below the generator voltage desired, and this DTC sets after 30 seconds. The charging system routine also has a high voltage branch ahead of the low voltage path. For a P0562 job, do not mix the decisions. Use this branch only if the scan data or the complaint points you there. Then come back to the low voltage diagnosis. Start that branch by inspecting grounds G113, G104, G100, G101, and G102 for loose, damaged, or corroded connections. Check the high current battery junction box the same way, and inspect high current BJB fuse F1, which is 275 amps. Battery voltage must be greater than 12.2 volts before and during this test, and do not have a battery charger attached during vehicle testing. Then do the visual inspection and verification. If an obvious physical cause is found, correct it. If not, start the engine, monitor the PCM Gen VDSD voltage PID, and decide whether it indicates 15.9 volts or less. If it does, keep going. With the engine idling, measure and record battery voltage, monitor Gen VDSD again, and compare the two. If recorded battery voltage is within plus or minus 0.5 volt of the PID, the system is operating correctly at that time, and the concern may have been connector related. If it is not within that window, continue the high voltage checks in order. Still on that high voltage branch, leave the engine idling, turn the headlamps on, set the heater blower on high, and measure voltage drop between the generator case and the battery negative terminal. The drop should be less than 0.5 volt. If it is not, inspect and repair the engine ground, generator ground, or battery ground for corrosion. If the ground side is good, view the PCM Gen VDSD PID. Use the Scan Tool Active command to set the PCM Gen VDSD PID to 14.5 volts. Then measure and record battery voltage with the engine still idling. If the result does not meet the 0.5 volt decision point against the PID, this branch supports a generator call. If it passes, increase engine RPM while still commanding Gen VDSD to 14 volts, and measure voltage again. If voltage is above 0.5 volt of the PID, check the generator wiring harness for looseness, corrosion, loose or bent terminals, and loose eyelets before making a generator call. If that RPM check passes, measure and record battery voltage at idle. Monitor PCM VPWR and confirm VPWR accurately displays battery voltage within plus or minus 0.5 volt of the recorded battery voltage. If it does, the system is operating correctly at that time, and loose wiring remains a possible intermittent cause. If VPWR does not track correctly on the high voltage branch, turn the headlamps and heater blower off, switch the ignition off, disconnect PCM C1232B, and connect a fused jumper wire from C1232B pin 50 to ground. With ignition on and engine off, measure voltage at PCM C1232B pin 1, pin 16, pin 17, and pin 31. Those voltages should be greater than 10.5 volts. If they are not, repair the affected circuits. If they pass, remove the jumper and move to the PCM ground side check. With ignition off, PCM C1232B disconnected, and ignition then turned on. Measure voltage drop at PCM C1232B pin 47, pin 61, pin 62, pin 76, and pin 77. The drop should be less than 0.5 volt. If it is not, repair the affected circuits. If the circuit checks pass, turn the ignition off, disconnect, and inspect all PCM connectors. Repair corrosion, damaged or bent pins, and pushed out pins as necessary. Then reconnect the connectors and make sure they seat and latch. Operate the system. If the concern remains, pause and check for current Ford service actions that apply to that concern. If none apply, this branch supports a PCM call. If the concern is gone, treat the issue as a module connection problem and fix the root cause of any connector or pin issues. Now, for the P0562 Low voltage path. Before chasing measurements, start with the basic system checks. Inspect the FEAD system. Look for abnormal ignition off, current drains. Inspect the battery. Check the high current battery junction box for loose, damaged, or corroded connections, and verify the mega fuse, which is 275A. Battery voltage needs to be greater than 12.2 volts before and during this test, and do not have a battery charger attached while testing the vehicle. Next, do the inspection and verification. Look over the likely areas for obvious physical damage or failure. If you find a clear cause, correct it before going deeper. If nothing obvious shows up, run the PCM self-test. If other generator control, battery monitoring, or communication faults are present, check what they mean first instead of forcing the P0562 path. If the self-test does not send you to another fault area, continue into the generator B+ checks. With the ignition off, disconnect the generator connectors and inspect them for corrosion, damaged or bent pins, and pushed out pins. Reconnect them and make sure they seat and latch correctly. Measure voltage at generator C102B pin 1 and compare it to recorded battery voltage. It should be within 0.5 volt of that battery voltage. If it is not, tighten or install a new generator B+ nut as needed. Verify the high current BJB Mega 2 fuse, 275A, is okay, and repair the circuit if the fuse is okay. If that fuse is not okay, identify the possible causes of the circuit short before moving on. If the generator feed checks correctly, start the engine, turn on all accessories, command Gen VDSD to 14.5 volts, and measure voltage at generator C102B pin 1. While measuring voltage drop, wiggle test the generator wiring and connections. Use a current clamp to measure and record current. Then divide voltage drop by current, VI, to calculate resistance in ohms. If resistance is greater than 0.3 ohms, inspect and repair corrosion in the generator B+ circuit or positive battery cable connections. If the loaded B+ path is not the problem, inspect the BMS. With the ignition on, run the BCM self-test. If the result points to the battery monitoring path, turn the ignition off, disconnect BMS C1689, and measure voltage at battery monitoring sensor C1689, pin 2. If the voltage drop is less than 0.5 volt, the path supports installing a new BMS. If it is not, repair the wiring circuit. If the battery monitoring path is not flagged, continue with the engine idling, headlamps on, and heater blower on high. Measure voltage drop at the generator case. It should be less than 0.5 volt. If it is not, inspect and repair the engine ground, generator ground, or battery ground for corrosion. If the ground drop is good, use the scan tool to view the PCM Gen VDSD PID. Command Gen VDSD to 14 volts, and compare recorded battery voltage to the PID. The recorded battery voltage should be within plus or minus 0.5 volt of the PID. If it is not, that result sends you to the generator clutch component test path later in the sequence. If the commanded generator voltage check passes, keep the engine idling with the headlamps and blower on high. Measure voltage and monitor the PCM VPWR PID. VPWR should accurately display battery voltage within plus or minus 0.5 volt of the recorded battery voltage. If it does not, repair high resistance or loose connections in the affected PCM power circuits. If it does, turn the ignition off. Disconnect PCM C175B. Connect a 5 amp fused jumper wire at PCM C175B pin 83. Then with key on, engine off, measure voltage at PCM C175B pin 22, pin 23, and pin 43. Those voltages should be greater than 10.5 volts. If not, repair the affected circuits. If they pass, remove the fused jumper wire and continue. Now measure battery voltage at the battery. With the engine idling and all accessory loads off, measure voltage while viewing and recording PCM VPWR. Then turn the headlamps on and the blower on high, measure again, and record again. VPWR should read within plus or minus 0.5 volt of battery voltage, with the loads on and off. If it does not, repair the affected PCM ground circuits. If VPWR tracks correctly under load and no load, Measure battery voltage at the battery again with the engine idling and all accessory loads off. Monitor and record PCM VPWR. Then momentarily accelerate the engine to wide open throttle and release. Repeat this step 4 to 5 times while continuing to monitor the PID. VPWR should stay within 0.5 volt of the recorded battery voltage when engine RPM increases. If it does, the system is operating correctly at that time. The concern may have been caused by a loose or corroded connector, so inspect and repair any connector or pin issues found. If no connector or pin issues are found, perform the battery drain check. If VPWR does not stay within that range during the RPM checks, the next move is the PCM connector inspection. When the failed command response check sends you to the generator clutch component test, use the clutch result to decide the next move. If the generator clutch is okay, check the generator wiring harness for looseness, corrosion, loose or bent terminals, and loose eyelets before installing a new generator. If the clutch is not okay, this path supports installing a new generator clutch. If the RPM change VPWR check sends you here, turn the ignition off. Disconnect and inspect all PCM connectors, repair corrosion, damaged or bent pins, and pushed out pins as necessary. Then reconnect the PCM connectors and make sure they seat and latch correctly. Operate the system and determine whether the concern is still present. If it is still present, pause and check for current Ford service actions that apply to this concern. If none apply, this path supports a PCM call. If the concern is no longer present, treat it as a module connection problem and address the root cause of any connector or pin issues. Keep verifications separate from the testing. After any repair on this P0562 path, operate the charging system under the same kind of conditions that exposed the low voltage concern and confirm the concern does not return. The takeaway is simple. Do not condemn the generator until the battery state, high current feed, grounds, BMS input, command response, and PCM power and ground tracking have all been checked in order. For more diagnostic training, visit stepdiagnostics.com.